So there are different ways that we can talk about interest rates. We can use the terms nominal rate, periodic rate, the APY, the APR, the effective annual rate, and simple interest. Let's start with the nominal rate, which is usually the quoted rate that you see in advertisements. The nominal rate does not take into account the compounding of interest on interest. That's why you see this lower quoted loan rate in advertisements for furniture, cars, and payday loans. The nominal rate is also called APR, which stands for annual percentage rate, so it has two names. The periodic rate is just the nominal rate divided by the frequency of payments. If you get a car loan that has a nominal rate of 12% interest due monthly, then the periodic rate would equal 12% divided by 12, which equals 1% per period. The letter M represents the number of compounding periods per year. In the example I just talked about, I used M equal to 12. In their example, they said M equals 4 for quarterly compounding and M equals 12 for monthly compounding. The effective annual rate, or EAR, or in your calculator EFF, is the annual rate of interest that tells you the actual rate of interest being earned for an investment or charged for a loan. So you can either earn interest or you can be charged interest. So that when this is higher, this is good when you're earning interest, and it's better if it's lower when you're being charged interest. So the reason why the effective annual rate is larger than like the nominal rate is because it converts a nominal rate into a rate that shows you the compounding of interest on interest, earning interest on interest, in other words. This is the best rate to look at because it is what is actually being earned or charged. There's a formula shown on the PowerPoint slide that shows you how to convert a nominal rate to an effective annual interest rate. There's also a much simpler way to convert interest rates back and forth from nominal rates to effective annual interest rates in the financial calculator. In this example, they are converting the 4% nominal rate to an effective annual rate assuming semi-annual interest payments. As you can see in the formula, the nominal rate 4% is converted to a periodic rate by dividing by M, which is 2. The formula is also raised to the power of M equals 2. Therefore, the effective annual rate is 4.04%. Again, this doesn't seem much different from the number 4%, but if we had more compounding periods and a larger rate, there'd be a bigger difference between the nominal rate and the effective annual rate. The calculator solution to this problem is done as follows. So you're going to look for the ICONV button, which is above number 2. So I have to hit second and 2, and then I'm going to put in a nominal rate, and my nominal rate was 4, and I hit enter, and I go down. I just skip past this is my final thing I want to calculate, to compounding periods per year. And it's compounded semi-annually, so I hit enter. And again, this is reminding me up here to hit enter. And then I can go down and back to my nominal rate, and now I'm to my effective annual rate. When I get to this effective annual rate, I just hit compute. And we see we get the same answer, the 4.04%. So it is important to know what an investment's effective annual rate is so that you can compare different types of investment choices. For example, you may have a quarterly compounded investment to compare with a monthly compounded investment. By using effective rates, you will be able to make an equal and fair comparison. In this slide, you can see several different examples of effective annual rates that have different compounding frequencies: annual, semi-annual, quarterly, monthly, and then daily. As the frequency of the compounding increases, the effective annual rate increases. So if you're going to invest in something, you want the most compounding that's possible. If you're going to be charged an interest rate, you want the least compounding possible. And then this is just a summary slide explaining when each type of rate is used. In this example, we see the effect on the future value of a 3-year $100 annuity with semi-annual compounding versus quarterly compounding. So here we have semi-annual and quarterly. And you can see the differences, $112.62 versus $112.68. But the quarterly compounding gives you the larger answer. And this is the formula way. We also can do this the calculator method. You can see that they have adjusted. This is the same adjustment that you would use for the calculator. In the I, you would, instead of putting 4 for the semi-annual, you would put a 2. And we'll go over this in a little bit. And instead of putting 3 for an N, we would put 6. And if it was quarterly, we would divide the 4 by 4 and put 1. And we would multiply 4 by 3 years and put 12 in for N. But if you like the formula method, then this is fine. You can use that. So the only time that the effective annual rate is equal to the nominal rate is when M equals 1, which means that it is annual compounding. So there's no point in calculating an effective annual rate here. When M is greater than 1, then the effective annual rate will always be greater than the nominal rate. And that's just kind of what we've been looking at all along. Now we are given a problem. What's the future value of a 3-year $100 annuity if the quoted interest rate is 4% compounded semi-annually? And it seems like a difficult question because you have like an annuity payment, but it's compounded semi-annually. So you've got your interest rate here, but your payment's occurring annually. So the timeline, it's over 3 years, but it's divided into 6 month periods. And then the periodic rate, like we were talking about before, is 4% divided by 2 because it's divided by 2 for semi-annual, and that makes this 2%. This is method 1, and it's really not recommended because it takes too long. But if this makes more sense to you, then it's okay to use. You can see that the future value of this annuity that's compounded semi-annually is $312.28. And here would be the formula if you wrote it out with the formula method. Or since we've just learned about effective annual rate, we could take our effective annual rate that we found for a semi-annually compounded 4% rate, which is 4.04, and then we would have an annual rate, an annual annuity payment of 100, and for 3 years we could put that for N. And so we would enter all of these into the time value of money keys, and we would get the same answer where the future value is $312.28. Also, we could use the same information and solve for the present value, or it could be like, what's the cost for investing in this choice that gives a $100 payment every year for 3 years, and it's compounded semi-annually. So you'd enter in all of your time value of money keys and compute the present value.